Okay, hi everybody. My name's Torin. I'm one of the co-founders of the Open Policy Agent project. This is an intro session to the project. What I'm going to do today is give a little bit of a background on the project and then a quick crash course into how OPA works, specifically around admission control in Kubernetes. And then I'm going to hand it over to Zack and Todd from Capital One and Intuit, respectively, who are going to talk about how they're using OPA to do admission control in Kubernetes in production. And then at the end, we'll have time for Q&A, so please save your questions to the end for all of us. Okay, so the Open Policy Agent, or OPA, is a general purpose policy engine. And what that means is that you can take OPA and you can basically use it in any system at any layer of the stack. So the goal of the project is to provide a building block or a library or a component that allows you to unify policy enforcement across a range of different technology. So we started the project back in 2016, early 2016, 3 years ago at Styra, the company where I work. And over the last year or so, we've seen a lot of growth in terms of the number of people that are actually using the project in production. So for example, companies like Netflix are using OPA to enforce authorization decisions or authorization policies across all kinds of internal resources. Companies like Chef are embedding OPA into products to provide end user authorization to their customers. Companies like Medallia are leveraging OPA to manage risk in their infrastructure. And then there are dozens of companies that are running OPA today in Kubernetes for admission control. So it's pretty cool. This is where we're at today. We have dozens of companies using the project across a bunch of different industries for different use cases. We're part of the CNCF now. We joined earlier this year in April, and we're a sandbox tier project. So it's still early stages, but the trends are pretty encouraging. We've had about 36 people contribute to the project. We have over 400 people on Slack asking questions, talking about their use cases. We have 1,500 stars or so, and we have over 20 integrations with other projects in the cloud native ecosystem. So why are people using OPA for admission control in Kubernetes? I think that there are a bunch of reasons why people are doing this, but one of the reasons is that as Kubernetes has matured and as more and more enterprises have put it into production, they've realized that in order to get to this idea of least privilege, in order to restrict the access that people have for security and multi-tenancy and risk management, you need to have a combination of role-based access control, or RBAC, and admission control. Okay, so anytime you want to enforce a policy that says that all deployments have these labels on them, like cost center or contact, or you want to restrict the host names in an ingress object, or you want to prevent vulnerable images from being deployed, you need to use an admission controller. Now the challenge with admission control is that the inputs to the admission control decision are very complicated, right? They're these complex, deeply nested data structures that you find that you work with in YAML files all the time. And so the question becomes, how do I codify or express rules that force invariance on the system? Moreover, a lot of the time, these policies are very organization specific, right? Everybody has a slightly different way that they run Kubernetes, and so the policies reflect that. And then on top of that, a lot of the time, the policies that people want to enforce depend on context. They depend on data or information from other systems in the organization, right? And so if you take all these requirements and you try to come up with a language to codify these kinds of rules, you end up with something very similar to OPA, or OPA's policy language. So the language that OPA gives you is kind of purpose-built for dealing with these deeply nested data structures. You can kind of dot into them and search over them and express assertions. You can leverage external context in your policies. And one of the neat properties of OPA and of the policies that you write with OPA is that you can query them in different ways. So not only can you take them and deploy them for enforcement, but you can also ask different questions. You can say, I want to dry run this. I want to run this in my development environment or as part of my CI process. Or I want to know what are all the deployments that violate my image policy, for example, right? So, oops. Just wait for that to come back. So there's a combination of things that make OPA a really good fit for these kinds of policies. So the way that OPA works with Kubernetes is similar to every other integration we have with OPA. It exists to basically decouple or offload policy decisions from some service. In this case, the service is the API server, right? So anytime you run kubectl apply or kubectl create, there's a request that goes to the API server. And inside of that request, there's a declarative resource spec that defines the pod or the ingress or whatever. And that's where the policy has to get enforced, right? And so what happens is that the API server calls out to OPA, and it supplies the entire extent of the resource to OPA. And then OPA takes that JSON object effectively, and it evaluates it against the policies that it has access to produce a decision like allow or deny. Now, in the case of admission control, it also produces additional information, right? So it's really important that you can, trace why why your deployment's being rejected or why your ingress is being rejected, right? And so the policies that you write with OPA can generate those error messages. They can say that you didn't supply these labels, like you didn't supply cost center, but you need to. Similarly, you can also generate like JSON patches, right? And so you can actually run OPA as a mutating admission controller. And so that's what Todd's going to talk about in a little bit. So if you want to learn more about OPA, we have a deep dive session tomorrow, and I'm going to go into more detail about how OPA actually works at the core, and I'm going to demo some features. And then I'm going to talk about some new work that we've been doing around data filtering with SQL and Elasticsearch, and some other work around taking Rego policies and compiling them down into WebAssembly. So if you're interested in OPA and you want to find out more about how it actually works and see some demos, come check out that session. So at this point, I'm going to hand it over to Zach, and he's going to talk about how they're doing admission control at Capital One.
Thanks. Hey, everybody. So Zack Abrahamson. I'm with Capital One Cloud Engineering. We're the internal engineering org that manages everything from AWS, and we're really trying to spin up Kubernetes, solving all those repetitive problems that everybody does in the enterprise in kind of one single place so that we can make them usable everywhere from our card division to our auto finance division. So a little bit about me. Already nailed that first part, so our tooling that we're building is basically a one canonical way to do Kubernetes cluster provisioning, and then the lifecycle management around that. We also build and provide a suite of integrations that kind of sit on top. So for those of you that are in an enterprise environment, if you have different enterprise services like logging, so we have an Elk service, we're providing those integrations that automatically are shipping your logs off to Elk, tie-ins with PagerDuty, Datadog, et cetera. And this platform is aiming to be multi-cloud and multi-tenant as well. And we're trying to do all of this with the regulatory constraints of a financial institution. So a lot of controls, a lot of things from InfoSec that are kind of declared in a design document somewhere that it's kind of up to us to make sure that all of our tooling and clusters are in compliance with. So Torin briefly hit on it. I know this is an intro session, so real quick for those of you that aren't familiar with the mission controllers, they're just code that let you police the incoming changes to your cluster. The two main value props for us are the governance, like I hit on before with InfoSec, and then just forcing that desired behavior. With most of the stuff that we do at Capital One, including our AWS deployments, we want to give people guardrails. We want to let them take advantage as much as possible of kind of the native services without being too heavy-handed and like really hitting them over the head saying, this is the exact way you do this thing. And OPA definitely lets us do that. And to enable them, it's just the enable mission plugins flag to Kube API server. And there's two basic types. Todd later will hit on the mutating one. Mutating mission webhook, that's going to let you actually rewrite. So you could say, hey, I'm going to take this request in, and even though you're not specifically specifying something, I'm going to do a rewrite so that you don't have to provide all the config. So if I don't necessarily have to know what namespace I'm going to end up in, you're going to rewrite that for me. And then I'll talk more about the first one. Should have put those in the opposite order. Validating, and that's just going to be the simple yes/no based on policies. So for Capital One, I already talked about security. So governance for us is pretty big. We have in AWS today, we have about 450 accounts. Kubernetes is growing in each of those accounts. And we need a way to know what our workloads are running, who owns them, who we can contact, who's responsible for them. In AWS, we use tags. Kubernetes, we use labels, right? So governance with labels, OPA definitely lets us do that. Configuration management, as part of these cluster builds, we have certain admin config, like root ingress, default root ingress and stuff that we don't want people to be able to stomp on, so it lets us kind of keep our configuration separate from the configuration people are trying to bring. And scoping as well. So if somebody wants to write a policy that's specific to a certain object or namespace, they can do that and not run into everybody. There doesn't need to be one canonical policy for this one big object. And at the end of the day, risk is our business, being a financial institution. So anytime that we can have an extensible way to codify the risk that comes down from InfoSec or compliance, it's a huge win, right? And if we can do that for our customers and users for free, internal customers and users for free, even better win. So what we like about them is that they're just a set of rules that kind of govern the behavior of your service. It's a really easy logical leap to go from that InfoSec policy that comes down to defining rules for your service, right? They're written in Rego, so for those of you that went to the keynote today, Liz Rice talking about her 300-line admission controller, that all it did was say deny if you're trying to create a service account. Rego lets you kind of do that in a human-readable way, something that's easily contributed to for multiple teams. And then, again, multiple policies can be written for the same Kubernetes objects. You don't have to say, this is how I'm going to handle all deployment creates. And then, yeah, minimal lines of code. So how many folks are running in an enterprise environment with Kubernetes today? Quick show of hands. Yeah, so this is a real simple use case. We did not know Liz was going to give the talk this morning, so she already hammered this if you guys saw that. But for those of you that don't want your developers or engineers pulling images, sourcing images from the internet, you probably have an internal image repository and you want to kind of lead them towards that. So this is the actual policy we use in our clusters. A couple helper functions are omitted here, but if you see the first thing here, we're going to actually declare this in our Kubernetes admission package. And we're going to use the Kubernetes namespace module that lets us kind of parse out everything. It's a deny policy that's going to respond with the message that's kind of defined below if you're not in compliance. We're going to listen for any time somebody tries to send a create of a deployment to the API server. And if it doesn't match anything in the valid deployment registry spec there, we're going to go ahead and deny, right? So you see right there, I removed it for kind of internal security reasons, but internal registry URL, replace that with whatever you're using, Artifactory, something else. It really is as simple as that. This is a really popular use case. I'm sure if you guys aren't doing it already, you're going to want to do it. It is really as simple as that, and that covers probably the most popular use case I've seen for admission control in the enterprise. So in addition to that, we can enforce annotations. So our cloud custodian product, a lot of what it does in AWS, OPA lets us do in Kubernetes right off the bat. We can prevent unwanted changes. So if we have a certain protected resource set, we can deny all changes that are incoming to that. And lastly, this lets us have a framework in a domain agnostic nature of OPA. We can kind of use this to take all of those incoming new security holes, new use cases, new risk management operations, and put them into policy at a later date. We're doing all of this today in Capital One. Very straightforward, very common use cases that I'm sure the other enterprise users have too. So a little bit about how we deploy this. OPA is just deployed as a REST API in a container, and then we put a service in front of that. The pod has a service count, cluster role binding. The policies live in config maps, and then the sidecar container, the kube management sidecar, takes a look at those config maps and then parses them for use by the main OPA pod. And this is kind of what it looks like. We run it all in its own namespace. So if you follow a request in from the left, somebody trying to create, let's say, a deployment, the API server would fire off the webhook. And at this point, your policy that was loaded as a config map would have already been processed by kube management. And then OPA can either apply approve or deny that incoming request based on the policy. And the way that we manage policies is our simple cluster provisioner here. All of our policies are stored in GitHub. So at cluster provision, we take those policies in GitHub, create config maps, and then the OPA kube management sidecar would start parsing those. So lessons learned in future direction. I don't want to sound too much like a shill for OPA, but this was probably the only thing we ran into, and Torin was nice enough to help out my colleague Jimmy to fix it. We were having issues where the webhooks weren't making it to the OPA server, and it was probably our stupid issue. All we had to do was add .svc to our no proxy rules. Very straightforward. There were some red herrings there that I think some other folks had run into, but they're not immediately indicative of anything. And then future integration, we do have our cloud custodian product. It's more of an after-the-fact governance. If you want to go do scanning and you want to go say, hey, who's all running deployments that are labeled with X, Y, and Z to take some action. So I think OPA and cloud custodian can really complement each other. And I think going forward, as you saw on the previous slide, we're doing all of our policy management at cluster provision time. So it's really tightly coupled to that process. I'd like to see them split out, right? So there's no need that policies need to be baked in at cluster provision. You could have a service that maybe connects to multiple Kubernetes clusters that takes this codified policy and applies as needed. Oh no, we might have frozen. Well, I only had my hiring pitch slide left anyway. So we're at booth P11. We're hiring from, we're hiring from everything from Go developers to SREs on our Kubernetes platform team. Definitely reach out. And there's a Medium article for this talk that my colleague that was supposed to give this talk wrote. Really good. It's out there. That's a bit.ly link to it. So thanks. And we're going to do questions at the end. Yeah.
Hi, thanks. Yeah, so Todd Eckenstand from Intuit. I'm going to be talking about how we use OPA to build secure multi-tenant clusters. So first, kind of give a high-level view. I work as part of the modern SaaS team at Intuit. There's a lot of interesting stuff going on here, but really what we're focusing on here is the lower-level Kubernetes secure multi-tenant clusters that we provide to our developers. And OPA is a key part of that. So really, why OPA? We already talked about it, validating and mutating webhooks, right? So it makes it easy to write policies that you can use. So I wanted to go back to one of Torin's earlier slides, just to drill home about the mutating webhooks. So the input can be any JSON value, and that would be your pod spec or any spec that's coming into the API server. And the output can also be any JSON value. And what you do in the middle, that's really the mutating webhook part. Right, so you can take that input, make some changes based on your policy, and then emit that back out. So it's a special type of admission controller. It's a mutating admission webhook, and you can have multiple webhooks that match that request get executed, and they'll be executed serially. And so you can make multiple changes to the same object, depending on how you want to layer those. And it runs in the mutating phase of processing the API web server calls. So how do we use this for multi-tenant? So at Intuit, each tenant is assigned a namespace within a given cluster. And then in that namespace, we only allow that tenant to run their pods, their resources on certain nodes. And so what we could do is we could tell all the clients, hey, go make sure you put in a node selector into all your requests and put in tolerations to all your requests, but we want to offload that burden for them. So instead, we use the mutating webhook to patch the node selector and the tolerations as appropriate into the pod spec. And here's an example down here where it's has a node selector matching the label for my IG, and then tolerations for my IG. So then this next slide, like I said, I was thinking about taking it out, but as our CEO says, repetition doesn't spoil the prayer. He's famous for saying that. So this goes back to validating, using a validation webhook to make sure you're only pulling from your own approved internal repository. So if you're not doing that, definitely do that. Really, basically the way it works is, here you're trying to pull something from Docker.io, the admission webhook denies that. Here you're change that same request, you're pulling it from your own repository, and it's allowed. All right, so that's the basic idea. So other use cases, we also want to deny requests to create a load balancer without the load balancer source ranges to avoid opening up that load balancer to the internet, for example. We might have other policies they're more for correctness, to fail fast. So for example, preventing ingress objects from being created without the appropriate security group. So that way, your API request will fail instead of trying to debug, what failed later. The other thing I wanted to mention was unit testing. So OPA can be run standalone outside, so as part of your CI system, and that allows us to do unit tests of policies. And as OPA becomes more and more critical to our infrastructure, testing is very important, especially as the policies become complex. So on the right side, there's just an example of testing that use case of an allowed image versus a denied image. Some challenges and future direction for us. What we'd really like to do is deny by default all API requests if OPA is not available, so really lock down the server. But there's sort of a chicken and egg problem there. If OPA is not available, then you want to fix OPA by doing something through the API server. So how do you do that, right? So that's the challenge that we still need to work out. But really, we need to have OPA running in an HA, high availability environment. The other thing is we'd like to have an OPA CRD. So we'd like to apply policies using normal Kubernetes constructs. And I think there is a project someone's working on for that. Also include vulnerability scanning, like was mentioned in the keynote, and more fail-fast checks. So now I'm going to escape out to a live pre-recorded demo. I'm glad you guys got the joke there. So here we're looking at our namespaces. And the namespace we're looking at is the CDP IKS test namespace. That's the sort of the multi-tenant namespace that I've been allocated. And that namespace is only allowed to run on node 233. So this node. So we're going to take a look at that node 233, described node. And really what it is, it comes down to having the right labels and having the right taints. So that's preventing other users from utilizing those nodes. Now we're going to apply a pod, try to launch a pod, but you'll notice we get a deny because we're not allowed to pull from docker.io, right? This is the admission webhook. So let's take a look at what's going on. We're going to look at our pod spec. We go over, we say, oh yeah, docker.io. And I change it to dockerintuit.com. Now, one thing I want to point out, we probably could have used a mutating webhook, right, to correct that from the user, but just because we could doesn't mean we should, right? So I think when you're looking at versus, admission webhook versus mutating webhook, really decide what you want to do. You don't want to give your developers unexpected behavior. I think it's better to fail in this case. So now we're applying the pod. The pod was successfully created. Now let's take a look. Now we want to look at the YAML of the running pod. I'm sorry, then we see that it is running on node 233 as we expect, as we want. Now we're going to look at the YAML of the running pod and compare that to the YAML that we specified as the input. So this is the mutated result, and really what it comes down to again is the node selector. The node selector has been added and the appropriate tolerations have been added. So now I'll switch back to my slides here. Okay, so and here's just a cleaner version, zoomed up version. So here's the original pod YAML. Here's the mutated pod YAML, and you can see that those have been added to the spec. That's all I had. So again, Intuit's been voted best company to work for 17 years in a row. It's a great environment, a lot of interesting stuff going on. We're at booth S22, so come hang out, talk to us about Kubernetes, some of the open source projects we have. We have a cool Argo and Argo CD demo talking about machine learning and how we're using Argo CD to deploy in production, and some other open source projects. And of course, as most people here, we're hiring, so stop by and ask us about that as well. Thanks.